Okay, next we are going to learn cyclic quadrilateral. Okay, so this is the diagram about cyclic quadrilateral. So how do we know this is cyclic quadrilateral? What are the characteristics of cyclic quadrilateral? How do I recognize cyclic quadrilateral? So these are some of the characteristics or properties of cyclic quadrilateral that you need to memorize. Okay, apart from the diagram, how does it look like, and then you need to know the definition of cyclic quadrilateral. It is actually a quadrilateral with its four vertices lie on the circumference of a circle. Okay, as you can see here, this is actually a quadrilateral, and its four vertices here lie on the circumference on a circle. So this is actually a cyclic quadrilateral. It's like you see a quadrilateral inside a circle, and the condition is its four vertices must lie on the circumference. If it is not, then we don't call it cyclic quadrilateral. Okay, apart from definition, cyclic quadrilateral has two pairs of interior opposite angles, where the sum of the interior opposite angles is equal to 180 degrees. For example, A, B, C, D are all the interior angles. So among these four interior angles, there are actually two pairs of interior opposite angle. For example, angle A is opposite to angle C. So this is a pair of interior opposite angle. Another pair would be B and D. Okay, because they are opposite to each other. So this is another pair of interior opposite angle. And the sum of each pair of these interior opposite angle is 180. So angle A plus angle C are 180 degree. And then angle B plus angle D is also 180 degree. That's why when we talk about sum of the interior angles of quadrilateral, it is always 360 degree. Because 180 plus 180, we will get 360. Okay? And then, as you can see here, there's another angle outside here. This angle is actually exterior angle. An exterior angle is equal to the corresponding interior opposite angle. So actually E is equal to A. Okay, I repeat again. An exterior angle is equal to the corresponding interior opposite angle. Okay? An exterior angle is equal to the corresponding, you move inside beside it, and then look at the opposite one. So that's the answer. Okay, next. Which diagram shows a cyclic quadrilateral? Okay, we will see one by one. Okay. Diagram 1. Is this a cyclic quadrilateral? All the four vertices lie on the circumference? Yes. Diagram 1 is a cyclic quadrilateral because its four vertices lie on the circumference of a circle. You see? All of the vertices lie on the circumference of a circle. How about diagram 4? Diagram 4 is also a cyclic quadrilateral because its four vertices also lie on the circumference of a circle. You can just ignore this center line. Just ignore it because this one is actually drawn to distract you. Okay, so you assume that it does not exist. So as you can see, this is a quadrilateral, and it happens that all the vertices are on the circumference of a circle. Okay, so this is a cyclic quadrilateral. And diagram 5. Diagram 5 is also a cyclic quadrilateral. So as you can see here, there are three distracting lines. So I cover it. Now you see, So you can see all the 4 vertices lie on the circumference of a circle. Okay, how about this one? This one is not, right? Because one of the vertices does not lie on the circumference of a circle. One of the vertex, not one of the vertices. One of the vertex. Sorry. One of the vertex does not lie on a circle. Okay. Okay, this vertex does not lie on the circumference of a circle, so we cannot say this is a cyclic quadrilateral. Okay, and this one also, there's a vertex here, also not lie on the circumference of a circle, so this is not a cyclic quadrilateral. Apart from 3 on the lie on the circumference, but there's 1 no. Okay, so this one also, one of the vertex is outside the circumference, it's not on the circumference, so this is also not a cyclic quadrilateral. Okay, next example, find the value of the unknown in each of the diagram below. Okay, for example, this one. So as you can see here, this is a cyclic quadrilateral, right? So regarding the calculation, we need to remember the sum of the interior opposite angle. So this angle and this angle are actually interior opposite angle of a cyclic quadrilateral, right? So their sum will be 180. So first of all, I make the equation. The sum of the interior opposite angle is 180 degree. So to find theta, it is equal to 180 minus 85. So we will get 95 degree. Let's say in the exam, you want to skip step 1. Is it okay? Yes, okay. Okay, no problem. You can start with the second step to save time. Okay, how about this one? Okay, can I apply the sum of the interior opposite angle, which is 180 degree here? I can only apply if I see that it is a cyclic quadrilateral, right? So is this a cyclic quadrilateral? Yes, because all of the vertices lie on the circumference of a circle. So I can apply this one. So I need to determine which two are interior opposite angle. X and 80 are interior opposite angle, right? And Y and 71, another pair of interior opposite angle. So X plus 80 equal to 180. So X equal to 180 minus 80 and X equal to 100 degree. And similarly for Y, Y plus 71 equals to 180 degree. And then Y equals to 180 degree minus 71 degree. And then, sorry, this one is Y, yeah? Y equal to 109 degree. Okay. And as for this one, this is also a cyclic quadrilateral because all of the vertices lie on the circumference of a circle. Okay, so we can apply the sum of the interior opposite angle. So these two are interior opposite angle. They are opposite to each other. So I form up one equation, 2x plus 4x equal to 180 degree. So 6x equal to 180 degree and x equal to 180 divided by 6. So you get 30 degree for x. Okay, another pair of interior opposite angle is 5y and 100 degree. They are opposite to each other. So their sum will be 180. So you move 100 degree to the right hand side, and then you will get 5y equal to 80 degree and y equals to 80 degree divided by 5, which is equal to 16 degree. Okay? Next. How about this one? Can I set that theta and 115 interior opposite angle of a cyclic quadrilateral? Can I say that this is a cyclic quadrilateral? No, right? Because one of the vertex is outside the circumference. It's not on the circumference. So this is actually not a cyclic quadrilateral. So you cannot apply sum of interior opposite angle, which is 180 degree here. So you come up this statement. You come up with this statement. Theta plus 115 degree is not equal to 180 degree. So there is no way for you to find theta in this case. You cannot apply that knowledge here. Okay? Because it is not a cyclic quadrilateral as I mentioned just now, so I don't want to repeat. Okay, so this vertex is outside, so this is not cyclic quadrilateral. How about this one? Can I set that theta and 180, their sum is equal to 180 degree? Can or no? Can or not? Is this a cyclic quadrilateral? You always ask yourself this question. Is this a cyclic quadrilateral? Are all of the vertices lie on the circumference? Let's see. 1, 2, 3, 4. Another one extra here. So this is not a cyclic quadrilateral. Okay, because this is not a quadrilateral. There are 5 sides here. Okay, 5 vertices here. So theta plus 110 not equal to 180 degree. Because there are 5 vertices lie on the circumference of a circle. Okay? Next example. Find the value of x, y, and z in the diagram below. Okay? To find x, okay, since x is in the lower part of this semicircle, so I cut it, okay, so that you could focus here. You can focus it here, alright? Because x is in the lower part of the semicircle, so I cut it and then I put it here. Okay, so in order to find x, I need to know what is this angle. Because I can use the sum of interior angles of the triangle, right? I can use 180 minus this one and this one so that I could get x. So I need to know what is this. So this is actually angle subtended at the circumference because it is formed by these 2 chords and a diameter in a semicircle. So actually this angle is equal to 90 degree. So to find x, we use 180 minus 90 minus 40 because this is a triangle. Okay, so the answer is 50 degree. As for y is the angle in the upper part of this semicircle. So I cut it like this. Okay, so this is a triangle. Y happens to be in this triangle. So as long as I can find this angle, I will use 180 minus this angle and this angle so that I could get my y. So I need to know what is this angle. So this is angle subtended at the circumference because it is formed by 2 chords subtended by the diameter inside a semicircle. So what is this angle? 90 degree. So to get y, we use 180 minus 90 minus 35. So you will get 55 degree. Okay, as the value for y. How about z here? Okay, so to get z, you will need to see at this cyclic quadrilateral. Okay, this one. I repeat, you see, I cut it because z is on the upper part, so I cut it like this, and then I could see that this is actually a cyclic quadrilateral because all of the vertex lie on the circumference, right? Semicircle is also part of the circumference. Okay, so to find z is very easy because I can use the sum of interior opposite angle, which is y and z. Their sum will be 180. I get my z, I get my y already, right? In the previous question. So in order to get z, I will need to use 180 minus 55 y here. Okay, so the answer will be 125 degree. Okay.